checking if a number works in an equality. It's just like testing if a key fits a lock. We take the number, put it into the inequality, and see if it makes the statement true or false. So remember our golden rule, and both parts must be true or only one. So every time we will test both sides step by step, and then use the AND or rule to decide if the number is in the solution set. Questions are not number. They use the words and or with facts. Okay, so A, Albany is the capital of New York, and New York is the capital of New York. Okay, so the first word here is true, but this is false. Since it used and, so it is false. Because and needs both true. B, this is true, and this is false, but it's used or, so the whole thing will be true. For C, this is false, but this is false. So both statement is false, it gives false. Then you can see that for A, you know that this is true and this is false because of and needs both answer to be true. Only it is true. But from here, we have one true and one false. It means false. Because N is picky, it wants perfection, both true, otherwise it says false. B, this is true and this is false. So, because it is or is friendly, if just one friend shows up or is happy, it is true. And C, this is false, this is true, because or, it is true. For D, both is true and it is N, so the whole thing will give true. Just for a reflection, N is like a strict teacher. Everything must be correct. However, or is easygoing friend. Only one needs to be correct. So every time you see N or O, think, do I need both or just one? That's the secret to never getting confused. 3 asks you which is true. Which one is true? So you need to figure out one by one. You can see that this is false. This is true. So it gives you false because it is N. And then this is true. And this is false. And it gives you false. This is false or false and it is false. This is true and true, it gives you true. So you can see that number 4 is true because both statements in the compound and statements are themselves true. So both are true for N. It gives you true. So this is the right choice. Okay, so for this question, you need to imagine that we are at a carnival. Each ride has a height rule. If you are too short or too tall, you can't ride. Today we are going to test each family member's height and see which rides they can go on. So step 1, you read each rule carefully and then look at the first one. H is 47. Is 47 larger than 24? So here they use and. You need to have both statements true to be true. So I can say that this is yes. And then here, true. 47 larger than 42. 47 lesser than 72. True and true, yes. This is yes. And then 47 lesser than 35, false. Or 47 larger than 60, false, no. So both false, it is no, a no. So here's 70. 70, it is still yes. 70 larger than 42, true. Okay, so for this, I already done for the table. You need to compare one by one. If it is a correct statement, then you write true. But you need to remember that and need both true, double tick only, it says true. So if it one false, then it is still false. Both false, it is false. But if you have or statement, both true, you have a true. One false, you still have a true. And if you have both false, you have false. Remember that N is like a strict teacher. And or is like easygoing. So which ride can every member go on is Twister. Twister have Tracy, Mark, and Marissa all yes, so the Twister is the only one. However, for the swing, we have no for Mark. For the wooden, we have no for Marissa, and teacups, we have no for Tracy. Again, a rule reminder, and both part must be true. If one is false, whole statement false. Or only one part needs to be true. If either is true, whole statement is true. So for number 1, we need to substitute x inside, x0 inside the inequalities. For this, I will have 2 lesser than equal 12. This is true statement. Or the other one, I have 3, 0 plus 1 lesser than negative 4, 3, 0 plus 1. So solve the bracket first. I have 3 times 1 lesser than negative 4. 3 times 0 is 0 plus 1. So negative 4, 1, 3, 1. 3 is less than negative 4. So here I have a false statement. So when I combine true or false, when I have a statement or one true is enough, so it is true. This is your final statement. Inside, then I just prioritize my parentheses. So 2, 3 over 3 less than 6. I will have here 2 less than or equal to 6. This is a true statement. And I have an n in the middle. So I substitute my 2 inside. I prioritize my bracket, my parentheses. I will have negative 2 times negative 1. So this is 2 less than 2. This is a false statement. And I have n in the middle. So n is picky. One false makes the whole thing no. So this is a no or false. This is true. And I have an or in the middle. So this is true. Both is true. And I have a statement of or is friendly, one true is enough, x is equal to negative 1 works, so this is true or yes. So x5, substitute x5 inside. The first inequalities give me a 3 larger than 3, and this is true. And in the middle, so 5 minus 3 over 4 is equal to 2. This is a half. equal 2. So this is a false statement. One part false and the whole statement will be false. So N needs both. It's just like doing a truth check. N is a strict or is friendly. So N, if one part is false, then whole is false. Need a double tick. Or as long as one part is true, the whole answer is true. Only one. So whenever you face a problem like this, don't panic. Just plug in the number, check each part, and then ask, do I need both or do I need just one? That's the secret to solving compound inequalities.